But without any further ado, ladies and gentlemen, give a big round of applause to Mr. Ericsson, system designer at OP5. Go ahead and put your hands together.
Thank you very much. Today I will treat you to an exciting journey through this presentation, which I haven't written myself. So I've added a few slides, but some of it may come as a surprise to me as much as it does to you. So let's see how this goes. Right, I'm going to be talking about Merlin, which is a redundancy recipe for Nagios. And since this presentation is not quite as cramped as the other one, I will also talk a bit about OP5 and OP5 Monitor, which is our product that we build around Nagios. The need for distributed monitoring and for high availability monitoring. Some brief stuff about concept and implementation, what our rules are for Merlin, some examples and scenarios, a pretty cool customer case, and, well, more info is a bit of a lie. It's just 2 URLs that you can visit at your leisure. OP5 is a company we started in 2003, I think. And when Johannes there actually hired me, I was the first employee there from a consultancy company that just span off into product land. We specialize in doing high performance and high availability installations of Nagios with redundancy in every layer and just generally very high performance. If you have a very, very large network, you will be interested in looking at things that we are doing because they will help out almost certainly. OP5 Monitor has the standard stuff that Nagios does for you, and maps, reports, all that jazz that everybody needs. We also have a need for distributed monitoring because even with very high performance code, there's only so much that one system can handle. For Mr. Wittenberg's case, with his 1.5 million services, you will be hard pressed to monitor that with any kind of sane interval on just a single system. So we need something other than that. This need is actually, first of all, it's a need for reliability. We have a lot of service providers as our customers, and it's just not good enough if their customers come and ask them at the end of the month, how much uptime did you have? And they say, well, we're pretty sure we only had like 20 minutes downtime, but we were upgrading our monitoring solution during that window, so we don't really know. That's not good because they're supposed to promise 99.97% or something like that. So, yeah, we need it for reliability and to make sure that the monitoring system is up all the time. We also need it for performance. Most of our customers run primarily active system checks, where they go out and ask the systems, because if you rely on them to report in their own problems, you're sort of trusting something that isn't working to report that it's not working, but it has to work sort of okay for it to be able to do that. So we rely mostly on active checks, actually. Not really sure what that limitations of the operating system means, but yeah. Yeah, possibly. Number of forks per second, I don't know. You will get to a limit where you really can't monitor a very large network with just one system. It's not doable. The need for distributed monitoring is usually it's very, very hard to measure a user experience from just one point in your network. Your users are most likely not sitting in one of your data centers and accessing your services. So it's pretty good to have something from the outside accessing your services on the inside as if they were a user. In order to do that, you need to have a separate system on a satellite node going out there. You could do it by using a redundant line somewhere that goes out to the internet and back in again. But not everybody has that. And by being able to put a poller outside your own network, you get that functionality very, very cheaply. That means you can handle. We have a bunch of customers that have done acquisitions and mergers with other companies, and it's a mess, a horrible mess of IP address conflicts. But if you have a poller sitting in that network and they can't talk to, they just need to be able to talk to each other. They don't have to be able to talk to each other's monitored segments of the network. You can have as many conflicts as you like, and it doesn't really matter. In terms of security, if you have red flag networks, like red zone networks, that you can't really access from the outside, but they can report their status to from inside to out. You can put a poller in there and have it just send its information back up to the master server. There's a point missing there. Not really sure what it was supposed to say. This is exciting, isn't it? Right. There are already solutions for doing redundant and high availability setups with Nagios, but they are all more or less clunky. They rely on one system doing nothing and then going out and activating itself if the other system goes down. But usually you get a couple of minutes of downtime before the failover system notices that the other system is up. So it has to sort of go to a lot of tricks, and when it does failover, you don't inherit the scheduling queue from that other system. So it could be looking at multiple check intervals where your monitoring just isn't working. It's not fun to try to explain that if you're a service provider and the national emergency broadcast network went down and you have no idea why. So yeah. We get load balancing and automatic failover. So the idea is that when you have two paired systems that are supposed to take care of the load, they just share it between them. If one of them goes down, the other one will immediately notice. Actually, not immediately. It may take up to 30 seconds if you just firewall it off completely. But if one daemon crashes or if one system goes down entirely, we get a signal that says, oh, hey, you're not talking to anyone anymore. And then we can immediately take over the checks, which are scheduled exactly the same on both servers. So we lose no time at all. And the network functionality, as I've already mentioned. Oh, redundancy is important, I was supposed to say. The missing bullet point. Awesome. So a few of the key features of Merlin is performance, of course. We need to be able to handle very, very large networks. Redundancy to ensure availability. I'm pretty sure those slides were supposed to be the other way around because it looks to be following down. Load balancing. It really does not make sense to have one system sitting idly watching and doing nothing at all. And before we had Merlin, we had a few super high availability customers that could not accept the downtime from one system. So they actually had 3 separate Nagios installations that were all doing active checking all the time, just because one of them might go down. So they got 3 alerts for everything. It's like, this is insane. It was like, yeah, we know, but we really need to have that. So, and distributed monitoring, of course, for geographical coverage or the red zone networks or what have you. So our solution for a scalable monitoring refers to an easy-to-use system capable of constantly changing to fit the needs of your business, because it's very, very easy to add new pollers or new peers or whatever. And it gives stability and performance. This is a worrying slide. Concept and setups. This is the Merlin logo. Merlin stands for Module for Effortless Redundancy and Load Balancing in Nagios. I'm good with acronyms. And it's, of course, used for setting up distributed Nagios installations or high availability installations. We started it in 2006 as a sort of prototype testing thing when we were still at Nagios 2.something back then. And we had a customer who needed the network of about 130,000 hosts distributed geographically all over the world, mostly on pretty shitty satellite links for the remote offices. This was a gas mining company.